Hello, I welcome you all to this another interesting screencast. The problem reads, determine the moment of the force Fc about the door hinge at A. Express the result is a Cartesian vector. The other problem is determine the magnitude of the moment of the force Fc about the hinged axis AA of the door. Both these problems are coming from the Engineering Mechanics and Statics textbook, 13th edition by R.C. Hibbeler. So we have been asked to find the moment at hinge A, as well as determine the magnitude of the moment Fc about the axis AA. Right. So we are going to use the vector analysis to work out this particular problem. And first things first, let's determine the coordinates of A, B, C. So A, coordinates A, in the x-axis, we have a minus 0.5. In the y-axis, we have -1, and in the z-axis, we have a 0. Then we have B, in the x-axis, we have minus 0.5, and then in the y-axis is a 0, z, 0, c. A c in the x-axis in the x-axis it's a minus, this is a minus 2.5. In the y-axis, I'll need to find this length here, so let me find these properties. So we have this one here that I'll need to find, this one here, and then we have this one here. This one here. Okay, let me make it a little bit longer. Alright, something like so. Then there we go. Okay, something like so. Great. Alright, there we go. Okay. So this one is just going to be equal to the length of is 1.5 of this door. So this is 1.5 sine 30. Okay. This is 1.5 sine 30. Then this one is 1.5 cos 30. Alright. So this is going to be equal to, let me just write this. This is 1.5 sine 30, and sine 30 is 0.5, therefore this is 0.75. Then this one is just going to be equal to 1.5 cos 30. This gives us a 1.3. Okay, a 1.3. Great. Alright, so I think we have it all. So in the y direction, we have 1.3 plus 1, which is a 2.3, minus 2.3. Then in the Z, we have a positive 0.75. Okay, I think we have everything. So now let's start working. All right. Case what? Case 4-170. What do we have? Right. So first things first, we need to convert the force Fc into a vector, and we need a unit vector along that direction. So say unit vector along CB is just going to be equal to RCB divided by its magnitude. Okay, and RCB is just B minus C. So let's subtract. So we have minus 0.5 B minus C. Yes, minus 0.5 minus 5 minus 0.5 minus 0.2.5, which just becomes a plus. So this becomes 2i, and then 0 minus 2.3, this becomes a plus 2.3j, and then 0 minus that just becomes 0.75k, and then divided by the magnitude, which is just 2 squared plus 2.3 squared plus 0.75 squared. Okay, so this is a 3.1 1.4. All right. Okay, great. So I think there we go. We have everything. Minus 0.5 plus 2.5, that's a 2. 0 minus 2.3, that's a plus. And a 0 minus 0.75, that's a minus 0.75. And therefore, the force Fc is just going to be equal to Fc itself times the unit vector, the magnitude itself times the unit vector UCB. And this is just going to be equal to 250 times the unit vector. All right, which we can just come and plug there in there like so. Okay, and therefore this becomes equal to Fc is therefore just going to be equal to, let's do the multiplication. So we have a 250 times 2 divided by 3.14. So this gives us 159.24 I. Then 250 times 2.3 divided by 3.14. So this is a plus 183.12j minus 250 by 0.75 divided by 3.14. So this becomes a 59.71k. So 250 by 2 divided by this 159.24. 250 by 2.3 divided by 3.14, that's 183.12, and 250 by 0.75 divided by 3.14, that's 59.71. Great. So this is our force. So once we found the force, we need also a moment in a vector arm, because we are saying we need a vector arm from there to there. There are two options. We can either use this or you can use that. Both of them can give us. Okay, so you have this one RAC, you have this one RAB. Okay, for me I'm just going to go with this one. Okay, I'll go with RAB. Right, so let me just delete this one there. Okay, I'll go with RAB. Okay, is that fine? You can choose whichever I want to go with. So my RAB is just going to be equal to RAB, that's B minus A. So minus 0.5 minus 0.5 is a 0. And then 0 minus 1, that's a 1J. And then 1J. So here it is just a 1J. Okay. It's a 1J from there to there. And it's in the positive direction, which is just equal to. So this is a 1J. Alright. So now let's work out. The moment there. So moment about point A as a vector is just going to be equal to RAB cross FC. Okay, we said this is also equal to RAC cross FC, right? So this is equal. So therefore our MA is just going to be equal to, we are using this particular tool. So we have I, J, K, RAB, it is just a 1, so it's 0, 1, 0. And FC is 59.24, 183.12, and negative 59.71. So let's work out this. So we have an I there. So I just becomes minus 59.71 minus, we have a J there. A J, what does it give us? A J, we have a 0, right? 0. Then plus, we have a K. What does a K give us? A minus, this minus that, just a minus 159.24. Alright. Let me just create a boundary here. Okay, something like this. And therefore, our MA is just going to be equal to, let's write our MA. Moment about point A as a vector is just going to be equal to minus 59.71 I minus 159.24 K. Okay, and the units for this is Newton meters, and the magnitude of this is just going to be equal to 59.71 squared plus 159.24 squared. So we get 170.07 Newton meters. Okay, let's squared plus 159.24 squared. So 170.07. Great. So this is the result at A. Now we are being asked to. Okay. We are now on case. The second case. The second case, which is case 4-171. 4-171. And we are being asked here to find the moment along the magnitude of the moment of the force Fc about the hinged axis AA. So what we need to do is, for us to find this magnitude, let's call it m underscore a. This is going to be equal to the unit vector along this axis dot RAB, okay, cross FC. And then this unit vector along this particular axis is parallel to the x-axis. It's parallel to the x-axis. So this is just going to be equal to I. Okay. This unit vector is just I. And then we have RAB, which we already calculated. RAB, we already know it. It's just also equal to RAB is just equal to J. So we have M dash A, which is just going to be equal to, using our tool. So instead of IJK there, we're going to use the unit vector UAA, which is just a 1, 0, 0. RAB, it is 0, 1, 0. And the force vector FC is 159.24 and 183.12, negative 59.71. Then M dash AA is just going to be equal to 1 by minus 59.71 minus just a 0 by, this is just a 0, just 0 plus, and this is a 0. Okay. And then M dash A is just going to be equal to a minus 59.71 Newton meters. The negative just shows that the moment is in this direction like this. Okay, using the right hand thumb rule. Okay, it's in the opposite direction of the x-axis. Right. So let me just outline the solution. For the first case, which is the moment about point A, we found the vector itself and this magnitude here, the one I'm just outlining. All right. And then for the moment about a hinged axis AA, this is the moment that we calculated here. All right. I think this is about it. And I hope the video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and see you in my next screencast.